Hello everyone, today I talk about the long-term trend research result of AZORult bot network. Overall, AZORult itself is shrinking its presence recently. However, an attacker used AZORult bot network for 52 months. It's pretty long and very interesting. So let's check the behavior on AZORult bot network. So here's the background. So as you know, malicious software is a major threat in cybersecurity field. In fact, there are a lot of malware families recently, and they are really active. So security practitioners and researchers provide a deep dive malware analysis result for a specific malware family, and also they tend to show short-term trend research result. Usually they are less than 1 year, and the contents are really useful to protect our organization because they contain a lot of IOCs, attackers' background, attackers' characteristics, and the TTPs, right? So by using those information, we can protect our organization. So, but how about long-term trend research result? So long-term trend research result is also useful. In fact, we would like to understand its macro trend to rise and fall of the malware trend. And also, recent malicious software, spreads additional payloads by their own bot networks, right? So we would like to know, so does a malware family try to spread the specific malware families like encrypted, or try to spread a variety of malicious software like red line stealer? So in case of encrypted, it tries to download additional modules to show actual malicious behavior, such as lateral movement and information stealing. So after that, try to spread a specific malware families, such as zero-day, TrickBot, or maybe ransomware, right? So in contrast to encrypted, red line stealer tries to spread a variety of malicious softwares, such as remote access Trojan, or as information stealers, or maybe coin miner. So if we can understand the differences, that might be a very useful information, right? And also, we would like to reveal the relationships with other malware families. So in this work, I will show an attacker used AZORult bot network and also Raccoon Stealer bot network to spread the same additional payload at the same time. Yeah, if we can understand this type of information, that would be a very useful information. So based on those benefits, I strongly believe long-term trend research result is very useful. However, if we want to get a long-term trend research result, we have to solve some challenges. So first, data structure. So, malicious software tends to be updated, right? So due to that, C2 communication protocols may be changed. And also encryption is very important. So due to that, we can't understand what's going on between C2 servers and the victim environment unless we have a decryption key, right? And also scalability is also very important. So if we check only a few C2 servers every day, yeah, we may be able to check them manually, or we can submit the samples which access to those C2 servers. After that, we can pass the analyze report. But if we have to check hundreds or thousands of C2 servers every day, those approaches won't be effective because they are time-consuming. And also, due to budget limitation, we may not be able to prepare enough sandbox instances. And also, we have to take care of evasion. So attackers may check an incoming request, and then they may realize, okay, we receive a suspicious request from the same IP address. So in that case, attackers may not a meaningful response to the victim environment. So AZORult. So in this work, I focus on AZORult to get a long-term trend research result as an example. So please allow me to describe what AZORult is. So AZORult is an old information stealer. It appeared in 2016. So this figure comes from Marpedia. So once you give a AZORult query to Marpedia, you'll be able to get a lot of blog contents on Marpedia. But unfortunately, most of contents don't mention a long-term trend research result. Only a few blogs mention that. So if I give a long-term trend research result to this context, that might be a very useful information in CTI community. So that's a part of motivation of this work. So in order to communicate with AZORult C2 servers, first AZORult try to create an ID based on victim environment information. So it tries to get a massing GUID, product name, username, and also computer name. So once AZORult gets all of them, it concatenates all of them into one string with hyphen like this format. And after that, AZORult try to send a check-in request to the C2 server with a generated ID. And once AZORult C2 servers accept the check-in request, it will send back a binary data blob to the victim environment. So here's a binary data blob format. So it contains a lot of interesting information. So let's check them one by one. So first, this field contains a string list. So the field contains a list of software names, register keys, and the folder path names, and also information they want to steal. Information they want to steal. So AZORult will use this data for the following execution. And the second part is the most important part. This part contains command information from AZORult C2 server. I will describe this part in the next slide. And lastly, embedded DLL files. So the DLL files themselves are not malicious, they are legitimate. But AZORult will use those DLLs to collect sensitive information on victim environment, such as cookie information or maybe browsing history. So AZORult uses three types of commands: F, R, and also I. So F means the target files attackers want to steal. So see this figure on second line and the third line, they are F commands. So the commands means the attacker wants to steal text files, document files, and also Excel files under documents directory and also desktop directory. So L command means the URLs for additional payload. So if the command contains L command, so in this case, fourth line, so the AZORult try to download a file from the URL and try to execute the downloaded file. And I means the victim computer's IP address and also country name, like this format. So in order to collect a binary data blob from AZORult C2 server for a long time, I decided to implement the AZORult emulator. I believe this approach will solve the previous challenges I described in the previous slide. So AZORult emulator needs a field information. The field information contains a list of AZORult C2 URLs. And once AZORult emulator receives the field information, AZORult emulator creates a dummy ID described in the previous slide, and send a check-in request to the C2 server with generated dummy ID. And once AZORult C2 servers accept the check-in ID, check-in request, AZORult C2 servers will send back a binary data blob to the emulator. After that, the emulator try to decrypt the binary data blob, and after that, try to save command information and also additional payload information to the local storage. After that, I investigate the downloaded file. So in order to communicate with VPN network, I used, in order to communicate with AZORult C2 servers, I used the VPN network to hide my presence. So implementation. I implemented the AZORult emulator with Python 3. It almost a few hundreds lines of code. And here's a massing spec for the evaluation. So evaluation. So I sent a dummy C2 request to 2364 C2 servers since 2019, January 27th. And also send a dummy C2 request twice a day. So it collected a unique 1237 additional payloads. So it's quite a lot. And so based on my brief analysis result, attackers spread almost 70 malware families by AZORult botnet attacks. So it's quite a lot, and it's very. So that means AZORult try to spread a variety of malicious softwares. So if you want to know the full family names, please read my paper. So let's check the macro trend of the number of AZORult C2 servers. So since I started this project, the number of AZORult C2 servers had decreased until 2019 August, and after that increased until 2020 February. After that, decreased again until now. So this trend shouldn't be surprised. As I mentioned earlier, AZORult is an old information stealer. So recent attackers have a lot of options for information stealer, such as Redline, MetaStealer, Luma Stealer, RisePro Stealer, or something like that. So that means recent attackers don't have a strong motivation to use AZORult as an information stealer. So don't forget this trend, but I found a very interesting exceptional case. So actually, this attacker used AZORult botnet network for 52 months. So please remember the previous slide. So the number of AZORult C2 servers had decreased until now, but nevertheless, this attacker used 52 months. It's quite interesting. And at least 95 C2 URLs were tied to this attacker. And furthermore, after I submitted my paper for this conference, then I checked the AZORult activity, and I realized, okay, this attacker still used AZORult botnet network this July. The duration was only a week, but this attacker still used AZORult botnet network. It's quite interesting. But you may have a question, so how do I decide the 95 C2 URLs were tied to this attacker? So let's check the idea with two commands obtained different timings. So see this figure. I got this command on 2019 November, and I also obtained the below command on 2024 March. It's almost 4.5 years difference, right? But you may realize the two commands are really similar. So for example, the two commands use the same library information. In this case, doctext and also OC, and also the target files are also same. So in this case, this attacker wants to steal text files under documents directory, and also they would like to steal several files under level DB directory for OC. And I checked the commands as came from 95 C2 URLs. I realized at least the attacker used the same 9 labels. So that means not only doctext and OC, but also PDF or recent JPEG, WinOS, ping, desktop text, and also text. So in order to calculate the similarity for command information came from 95 C2 URLs. As for the 9 labels, I use Jalwinker distance to check the command similarity. The Jalwinker distance is a very popular approach to calculate the similarity between two strings. So this figure shows the similarity. So in this case, 1 means the two strings are exactly same, and 0 means that they are not matched at all. So as you see, most of the plots are close to between 0.9 and 1.0. So that means the command contents have a strong similarity, right? So that's why I've concluded the same attacker prepared commands came from 95 C2 URLs. So let's check the campaign overview. So at least I found 4 campaigns. So the first campaign started from 2019 November to 2020 March. At that time, I found 15 seats URLs. And the second campaign started from 2020 March to 2020 June. At the time, I found 96 URLs. The third campaign was longer than the previous two campaigns. It started from 2020 June to 2020 March. It almost 1.5 years. Yeah, and I found 43 seats URLs. And lastly, fourth campaigns started from 2022 March to 2024 March. It's almost 2 years. And at that time, I found 18 seats URLs. And also, as I mentioned earlier, this attacker used AZORult to work on this drive. So if you want to know the full campaign detail, please read my paper. So, but you may have a question. So, what's their motivation by using AZORult? So the answer is they would like to steal a lot of sensitive information on victim environment. So here's the actual command comes from the C2 server operated by the attacker. So it contains a lot of information. So I will summarize this part. So first, they would like to steal password manager and also authenticator information. As for keepers, VWarden, Windows, authenticator, and also OC, like this format. And also, they would like to steal crypto wallet information as for JAX and Atomic, like this format. And also, they would like to steal files tied to cryptocurrency name. So see this figure. So you will realize it contains a lot of cryptocurrency names, such as Ether, Wallet, Coinbase, Bitcoin, Electron, BTC Market, or something like that. And not only PDF files, but also I found the document files and text files, and also picture files. It's quite a lot. And finally, the attacker wanted to steal files under specific folders. At least I found the recent documents and also desktop directory. So most of the attackers, most of Windows users tend to save their own documents under documents directory and also desktop directory. And those files automatically synced under recent directory, right? So that's why I guess the attacker specified the 3 directories. And also, this attacker showed the additional payload spread campaign in their first campaign and also the third campaign. During the 2 campaigns, they tend to use remote access Trojan and also Windows Defender Disabler. So by using Windows Defender Disabler, the attacker can decrease Windows security level setting on victim environment. So after that, they can easily infect with remote access Trojan or maybe additional information stealer or maybe coin miner or quick banker. It's a very clever way, right? So, and furthermore, I realized this attacker used AZORult bot network and also Raccoon bot network to spread the same additional payload at the same timing. So in order to get this type of findings, I actually implemented the Raccoon Stealer emulator and operated it for a long time. And by correlating the both findings, finally I could get this type of information. So this table contains AZORult and also Raccoon domains. And also it shows the start date and also end date. And during the date, this attacker spreads the same additional payload with the same file name. And in the right side, I showed mapping information between a file name and also malware family name. So for example, nw.exe means netwire and ac.exe means async. So this type of information shows why we need a long-term trend research result. So if we do a long-term research result, we'll be able to get this type of information. And by using this information, we'll be able to understand attackers, maybe characteristics and their behavior. That I'm sure that's a very useful information to understand the attackers. So discussion. So I use AZORult emulator to collect the binary data blob for a long time, but I guess it still has a limitation. So maybe attackers check a VPN network. So as I mentioned earlier, attackers may check incoming request, and they may realize, okay, we receive a suspicious request from the same VPN network. So I try to change a VPN exit node frequently, but they may still, okay, we receive suspicious requests from the same VPN network. So in that case, attackers may not binary data blob to the malware emulator. And also, attackers may check activity pattern. Actually, the recent version of Raccoon Stealer detects an unusual activity pattern. So in that case, I carefully implemented the AZORult emulator as if it behaves as an actual AZORult. But if the implementation is not good, attackers may realize, okay, this behavior seems to be kind of bot activity or maybe kind of emulator activity. So to avoid, in order to avoid this type of evasion technique, maybe we need to prepare a dirty IP address pool for this activity, and try to rotate them frequently and send a check-in request modestly. That might be a potential solution to avoid this type of evasion technique. And also, in the previous trial, I showed an attacker use different bot networks to spread the same additional payload at the same time. But actually, I found another attacker used Amadi and Redline Stealer to spread the same additional payload at the same time. It's very similar behavior, right? And I presented my findings in the different components. So the two results means, so if we do a long-term trend research result for a variety of malicious software, we will be able to find similar type of findings. So this type of information is a very useful information to understand the attackers and characteristics and attackers' background, or maybe in the TTP. That might be a very useful information. That might be a very useful information in CTI committee. So that's why I strongly believe a long-term trend research result is a very important. So conclusion, I investigated the AZORult bot network around 5 years. I scanned 23 64-6 URLs, and it collected the unique 1237 additional payloads. And based on my analysis, attackers spread almost 70 malware families by AZORult bot network. So AZORult spreads a variety of malicious softwares. So as findings from long-term trend research result, an attacker used AZORult bot network for 52 months. Although the number of AZORult seeds servers had decreased, it's counterintuitive. So that's why very interesting. And also, this attacker showed a joint operation with Raccoon Stealer to spread the same additional payload at the same timing. So if we do a long-term trend research result for a variety of malicious software, we'll be able to find similar findings in other malware families. So that might be a very useful information to understand the attackers. Yeah, that's it from me. Thank you very much for listening.